What's up? I'm going to turn my volume all the way up just so I can hear stuff. Hi, General Science. Miss Marshall coming at you in my ratty Walmart sweatshirt, but we're here. Unedited, unfiltered, just trying to help you out the best I can. So last week, I noticed that I gave a very large assignment to you guys and expected it done in a week, and that was my fault. That was my bad. And so I extended the deadline for you guys until this Friday. So hopefully you've had some time to work on it. I've noticed a couple of you asking questions, having them kind of flow in. And I think that that is wonderful. I'm so happy that you guys have been asking me questions and commenting on the assignment. But I wanted to make this video to kind of cover a bunch of questions that a lot of you guys have been having over the past couple of weeks. And so what you can kind of see behind me right now is just a document. These are some of your unit example problems. I went through and based off of how many of you said you wanted help on what thing, I went through and kind of figured out some of the practices. And of course, I'm going to post this document when it's all filled out, as well as this video, so that you guys can see and kind of follow along if you'd like to. So you've seen all of these questions before. Every single one of these questions is an example problem that you've done in the past. Of course, it's not all of the problems, and I'm not going through every single one, but I'm going to go through enough to kind of give you an idea of how to do these problems, what an ion is, what an isotope is, all that fun stuff. Ooh, wonderful hair. So we're going to fix that. So let's start from the very beginning. It's a very good place to start. I'm going to make me a little bit smaller. So starting with building the atom simulation. So this was your simulation. You should have seen this with a net charge and a mass number, stable or unstable. Make sure you clicked orbits as well. So this is your build an atom simulation. At the time, we had no idea what a net charge and what a mass number was, but we know it now. We know that a net charge is when we have unequal protons and neutrons, or unequal protons and electrons, and that our mass number is our protons plus our electrons. So you should have built beryllium. Now beryllium, notice how I put one proton in, now I have hydrogen, 2 is now helium, 3 is lithium, 4 is beryllium. Okay, so I put 4 protons in. Remember, number of protons determines my identity of my element. So here's beryllium right there. This is unstable. Your next task was to add neutrons until it was a stable nucleus. There we go. So I added now 5 neutrons. You can see it up here. 5 neutrons, 4 protons. So my mass number should equal 9. And it equals 9 because if I counted up all my protons and I counted up all my neutrons, that was my mass. The net charge right now is +4. Why? Because I see 0 electrons in this beryllium atom. 0. The instructions told you to put 4 electrons. 1, 2, 3, 4. And now we can see our net charge. So here are some of the questions that were commonly missed in the build an atom simulation that I kind of wanted to go over and check with you guys. So let's go back here. What determines the type of the atom? Give examples. I don't know how many of you forgot to give examples. Every time I say give examples, that means you got to tell me something. So we just saw in the build an atom, what determines the type? I take a proton away, now it's lithium. I put a proton back, it's back to beryllium. So if I do that with neutrons, it stays beryllium. If I do that with electrons, it's still beryllium. So the thing and the particle that determines the identity of an atom is going to be our protons. And when I say give examples, that means tell me. And I just gave you a couple. Beryllium has 4 protons. Lithium has 3 protons. Done. Okay. So our protons are what determines what type of atom. Now, I understand that this question could be This question could be rewritten to say what determines the type of element. I think that would have made it a little less confusing. But when we say type of atom, we mean like what type of element it is. Okay, so did your mass number change when you added electrons? What particles changed the mass number? So just the way that this question is written, you should be able to tell that electrons are most likely not the thing that changes the mass, because I asked you a separate question. There's 2 questions in this one thing. That means you have to make sure you answer both of them. Okay, so let's double check here. My question is, did your mass number change when you added electrons? So let's look. My mass number right now is 9 with 4 electrons, 5 neutrons, and 4 protons. So I'm just going to take electrons away, and I'm going to see what happens to my mass number. There's 1 electron, 2 electrons. Okay, our mass number isn't changing. Okay, I took away all my electrons. My mass number didn't change. Maybe it'll change if I add on a bunch. Let's add on as many as I can. Okay. Mass number still isn't changing. Still adding, still adding. Okay, so my mass number didn't change at all. So to answer the first part of the question, did your mass number change when you added electrons? I'm going to say no. The mass number didn't change when I added or took away electrons, because I tested both. Now the question here is, what particles change the mass number? Okay, so I tried electrons. That didn't really work. So let's try, I'm going to remove all of these so they can stay, so it can be neutral again. There we go. See, neutral atom. So I'm going to now try neutrons, see if that changes anything. Whoa. I added another neutron. Now I have an unstable nucleus, but I have a mass number of 10. What happens when I add a proton? Oh, proton. Changed it to boron. Also changed our mass number to 11. So to me that says protons and neutrons change the mass number. Okay, so there we go. We have 3 subatomic particles that we need to pay attention to: protons, neutrons, and electrons. And we know that protons and neutrons change the mass number. Protons change the identity of the element. Electrons determine the charge. So that's kind of the answer to question 3. What happens when protons equals electrons? So here I have 1, 2, 3, 4, 5 protons. Oh, I still want to do it for beryllium. So let's make this stable again. So here I have 1, 2, 3, 4 protons. I have 4 plus charges here. And I have 4 electrons. So protons equal electrons. I see a net charge of 0. Okay, so there we go. When protons equals electrons, equals electrons, the net charge equals 0. Okay, there's the first part of my question. Done. What happens to when protons do not equal electrons? So let's look. I'm going to take away some electrons. 1, 2. Okay, so I took away 2 electrons. Now I have a net charge, and our net charge is plus 2 because I have 2 more protons or 2 more plus charges than minus charges. Now, at the time that you were doing the simulation, you had no idea what an ion was, but now that you know, you should be able to see why this is an ion. So when protons do not equal electrons, there is a net charge. Oops. So this is all I was looking for those questions. Just telling me if there's a net charge, if there's no net charge, what's going on with those atoms. Now you can kind of see a build an atom simulation is pretty good when we're trying to figure out ions and isotopes as well, but we'll get there. So that's from your build an atom simulation. These were the most commonly missed questions, and so I just wanted to go over it to make sure that we knew what we were talking about here. So we're going to go on to the next one. That's name the element worksheet. You had 2 parts of this worksheet: a giant table of information that you had to fill in, and you had some who am I questions. So you had to really use your periodic table to figure out all of these different things. So I'm going to start with copper here, because we need to figure out a lot of pieces of information for copper itself. So a lot of you might have access to this periodic table. That's great. I'm also going to be showing you on this periodic table. It's called the Dynamic Periodic Table, or ptable.com. I suggest that you go to that. I will include the link in this video link as well. ptable.com. It's a pretty helpful. It shows you a lot of different things. It breaks the elements up into their, or it breaks the periodic table up into some different categories. It has some other things that I think will be important. So let's just go. My first example, I'm going to be working on copper, this guy right here. The very first thing it wants me to figure out is what its symbol is. Okay, I'm going to go find copper. Here it is. I'm going to click on him so we can kind of see. No, I don't want to click on him. So I know copper's right there. My atomic symbol is the two letter abbreviation, I guess, of the name. So my symbol for copper is capital C and a U. Okay, we always capitalize the first one. We lowercase the second letter. Okay, so my atomic number now. I need to figure out what my atomic number is. My atomic number for copper is going to be, I almost pointed to it with not using my mouse, is going to be this number right here, 29. Now I know that this is the atomic number and this one isn't, because my atomic number shows me my number of protons. And I cannot have fractions of protons. So it's going to be the whole number that's on the periodic table. So 29. Go back here, fill this in, 29. Now, my mass number is the other number that I see in the periodic table, and that's this guy, this 63.546. Now, I told you in the directions that you needed to round that to the nearest whole number. So when I'm rounding 63.546, it honestly doesn't matter where you round it to, but I see 63.5, so I'm going to round this to 64. You can round it down to 63, doesn't matter. 63. Now, whenever we're doing things like this and we're taking atoms from a periodic table, we are assuming that it is neutral every single time. Why am I mentioning that it's neutral? Well, when we have a neutral atom, protons equal electrons. I'm going to type that up here. In a neutral atom, protons equal electrons. Okay? This is important for both of these columns here, this protons here and electrons here. So what's also important to note is that my atomic number equals my number of protons. So my atomic number for copper is 29. That means because my atomic number equals my number of protons, that my number of protons here is also 29. Now, because I have a neutral atom, and I know I have a neutral atom because I did not tell you otherwise, my protons equal my electrons. So my electrons are in this column here. This is also going to be 29. Helpful. Now I need to figure out my neutrons. And what's helpful is that we just figured out in the simulation that my neutrons and my protons contribute to the mass number. So we all know this mass number is equal to protons plus neutrons. Now I know what my mass number is, and I know what my protons are. So I'm going to manipulate this equation just a little bit, and we're going to get neutrons are equal to the mass number minus protons. So that's what I'm going to do. In my calculator, I'm going to do 63 minus 29, 34. That's my number of neutrons. And my entire row is filled out, done. Okay, so this is when we're given the element name. Now for this top row right here, we are just given the element symbol. So we need to be able to find the element symbol. Now what's lucky for us is we're also given the number of protons. So I'm going to go to my periodic table again, and I'm going to look for PT, but I also know that it has an atomic number of 78. So if I find a row that's close to 78, oh, here it is, and, oh, I passed it. Platinum. No, I don't want to click on it. Okay, so we are looking at platinum. Platinum has an atomic symbol of PT. It has an atomic number of 78. We have that information here. I'm going to type in my element name. I know my atomic number is equal to my number of protons. And because this is a neutral atom, I know my protons are equal to my electrons. We've just filled out most of this table just by looking at my number of protons. Pretty helpful. Now I need to figure out what my mass number is and what my neutrons are. And I can't do that with any of the information that I have here, which means I have to look at my periodic table again. Okay, so I'm looking at my periodic table. I'm going to platinum. Right now, the atomic mass is 195.08. I'm going to round that down to 195. 195. Okay, now I don't, I put that in the wrong spot. 195. Delete. Okay, so I know that my mass number is 195. I know my protons are 78. So my neutrons are equal to my mass number minus my protons. So in my calculator again, you can also use your phone, but I'm not going to do that. 195 minus 78 equals 117. 117. So in my neutrons, I have 117 neutrons. Now we can always double check if you want to. If I have 117 neutrons and I have 78 protons, if I add those two together, I should get my mass number. And look at that. Good. So we've checked our work. For this last one, all I'm given is an atomic number, this middle one right here. That's all I'm given. I'm not given any symbol or name or anything like that, just my atomic number. Lucky for us, what we know is that our atomic number is equal to the number of protons. So let's just put that in there right now. This is a neutral atom, which means my protons are equal to my electrons. Cool. Let's put that in there too. Now, from our build the atom simulation, we know that protons determine the type of element. So if I know my number of protons, I know what my element is. I have to go to my periodic table, though. Find the atomic number of 92. Boom. Looks like my element is uranium with the element symbol U. Beautiful. So now I can go back to my periodic table, figure out what my mass number is, and figure out what my neutrons are. So my mass number for uranium is 238.03. I'm going to run that down to 238. And then I'm going to use my lovely calculator, and this right here, neutrons equal the mass number, 238, minus your number of protons, which is 92, 146. That's my number of neutrons in uranium. And there you have it. That's how you fill out that giant table that I gave you, I think, during week 2, week 3, one of those. Now, there's a second part to this Name the Element worksheet, and that is the who am I questions. You had a bunch of questions that was inside of a question mark, and you had to identify what each of the element was. Again, these are the most commonly missed ones that people ran into that I want to double check. The biggest problem was that most people thought that atomic mass and atomic number were the exact same thing. And it's not. Okay, we know the atomic number is our number of protons, our atomic mass is our protons, and our neutrons. So we have to pay attention to which one is which. So for question number 1, it's a nonmetal. It's in the halogen family, and it has an atomic mass of 35. So in our dynamic periodic table, I'm going to look at the nonmetals. Great. In my nonmetals, I know that, look over here. In my nonmetals, I know that my halogens are right here, group 17, my halogens. So I know that this element that I'm trying to find is in this row, right? Or this column right here. Now in this column, I have to look for an atomic mass of 35. Most of you put bromine. Bromine is not correct because bromine has an atomic number of 35. But chlorine, right above it, has an atomic mass of 35. So I go back here, and chlorine is my answer because of this keyword right here, atomic mass of 35, not an atomic number. You need to read both parts. Atomic mass and mass number are essentially the same thing. So that needs to happen. Miss Benedict is building an airplane, a giant one. She just told me that it didn't work. Okay, so let's look at our next one. Period 4 lowest atomic mass in the period. Remember, a period is a row. So I'm going to go to my dynamic periodic table. I'm going to go to my fourth row right there. It's nice and highlighted. And I'm going to find the element with the lowest atomic mass. Not the lowest atomic number, the lowest atomic mass. So I see, oh, well, if I go to 31, that's gallium. It has an atomic mass of 69.723. Oh, but if I keep moving to the left, they get lower and lower all the way until I get to the very left side of the periodic table. That's potassium. Potassium has the lowest atomic mass in period 4. A lot of you put hydrogen as the answer, which is the lowest atomic mass in the entire periodic table. Helpful to know, but not what the question was asking. Okay, we're looking for a period 4, which means potassium is my answer. Now this last one, I think we were mixing up what each subatomic particle did. So for this last one, 12 neutrons, it's a metal, and 11 electrons. Most people put magnesium. Magnesium is not the correct answer because magnesium has an atomic number of 12. But if it's neutral, it doesn't have 11 electrons. It has 12 electrons. And so we need to find the element that has 11 electrons when it's neutral. Now we know from up here, a neutral atom has protons equal to electrons. So if my electrons are equal to 11, that means my protons are equal to 11, which means my atomic number is equal to 11. Sodium. Sodium has an atomic number of 11, which means it has protons equal to 11, which means because it's neutral, it's going to have electrons equal to 11. Okay, there's the atomic symbol for that, and for that one, and for that one. Now, if at any point you have questions about, my explanations or these questions, please just comment on the video or a private comment if you'd like to. But I would prefer if you commented so that the entire class could see the question, because I guarantee if you have a question, other people do too. Okay, let's go to Lewis dot structures. We've talked about neutral atoms. These are still neutral atoms here. I'm going to do this. So Lewis dot structure practice. We're about to do the same thing that you just did up here, determining protons, neutrons, and electrons. I think we should do that first before we move on to do the actual dot structure. Helium was a tough one that most of you missed, and I understand why. So if I go to my periodic table, move me so I'm not in the way. Helium is in group 8, right? We can see that. It has an atomic number of 2. So I know that my number of protons equals 2, and protons equal electrons, 2. My neutrons, I'm going to find it in the same way. It has a mass of 4.0026. It's fine with us. We're going to round it to 4. And our mass number is equal to our protons plus our neutrons. Our neutrons are equal to our mass number minus our protons. So if I have 4 minus my number of protons, which is 2, I'm going to have 2 here. Now here's where a majority of us goofed up, which is okay. We were talking about valence electrons. And valence electrons, remember, are the electrons in the outside of the atom, the very, very last shell. Helium is in group 8. Group 8, or column 8, most of these guys here, are going to have 8 valence electrons. And so that their symbol for their Lewis dot structure is going to look like this. 1, 2, 3, 4, 5, 6, 7, 8. Oh, you can see that. The issue that most of you did was you also included helium in this group. Now I want to go back and see that helium only has 2 electrons. It doesn't have 8 electrons. If it had 8 electrons, it wouldn't be a neutral atom. So we only have 2. Move me over here. We only have 2 electrons, so we have to pay attention to that. It only has 2 electrons, which means in my Lewis dot structure, I can only include 2 electrons. Helium is an exception to the octet rule. That's why the octet rule is a rule. It's kind of like more of a guideline than a rule. And so I want to put in here, before I draw the Lewis dot structure, helium is an exception. Nope, I'm spelling that wrong. To the trend in the periodic table. Helium only has 2 valence electrons, right? Because it's neutral. So when I draw my Lewis dot structure, remember how I showed you in the other video, you're going to insert a drawing, a new drawing. I forgot I was on camera for a second. I'm going to insert a new drawing. I'm going to patiently wait for it to load. There we go. Whatever, I don't care. Okay. Give myself a little text box. Go away. Putting my element symbol in the middle. Cute enough, it works. And then I'm going to add a shape. I'm going to add a circle. And I want it to kind of look like that. So remember, electrons 1 through 4 go around this little box. And it's helpful that there's a box here because this is how we need to kind of assign sides. 1, 2, 3, and 4 go here. And then they get paired up. Then they're paired. 1 there. And I'm going to copy by Control C. I'm going to paste by Control V. 2. That looks very bad. But you get the idea. I'm going to save and close it. So there's helium. Same thing happens with, I'm going to get rid of this. We don't need to do this one. Same thing happens with aluminum. So aluminum, I'm going to go to my periodic table. Boom, there it is. It has an atomic number of 13, and it has a mass number of 27. I'm going to fill this out. Has an atomic number of 13, electrons equal protons, and then my mass number is 14, which means, or my mass number is 27, which means my number of neutrons is 14. So again, I'm going to make my Lewis dot structure. And my Lewis dot structure depends on the number of valence electrons that are in aluminum. The valence electrons are determined by the group that they're in. Group 13 has 3 valence electrons. So aluminum is going to have 3 valence electrons. We're going to insert another drawing. New one. We're going to do the same thing. 3 valence electrons. Patiently waiting. Patiently waiting. Finally. Okay. My symbol for aluminum is Al. And now I'm going to put in my 3 valence electrons. 1 here. Yep. Copy, paste. 1 there. Paste. Whoa, whoa, whoa. And 1 right there. Save and close. What most of you missed was that you were trying to pair these 3, and it ended up looking like, make me really big. A lot of you put this down. There's aluminum. You put this 1, 2, 3. Oh, my lights. There we go. So a lot of you put this down. 1, 2, 3. Electrons 1 through 4 need to be on either side of the element symbol. We cannot pair them up here. This guy needs to go, it can go here, or it can go here. Either way is fine, as long as the electrons stay around each other. Calcium did the same thing. Some of you tried to pair it. And that's not how that goes. You cannot pair electrons 1 through 4. If I had, let's say, 6 valence electrons, like for oxygen. The way that you would do this is I would start here. This is electron 1. This is electron 2. Here's 3, 4. Now I can start pairing. 5, 6. That's what it looks like. Because I can start pairing because I have more than 4 electrons, valence electrons. Okay? So that's where most of those issues were with the Lewis dot structures. Now let's talk about ions and isotopes. So, what is an ion? You guys learned about that last week. An ion is an atom with unequal protons and electrons. Unequal protons and electrons. So, questions 5 through 10 wanted you to first focus on ions. A particle, whichever one, contains 8 protons and 8 electrons. Helpful. So it wants us to say what this element is. Well, if it has 8 protons, I need to go to my periodic table and I need to look at the atomic numbers. And it looks like oxygen has an atomic number of 8, which means my element in question here is oxygen. Very helpful. Now our charge is determined by figuring out our protons and our electrons. Couple ways that you can do this. Your charge needs to focus on the total number of protons and electrons in an atom, not just valence electrons. For oxygen, I have 8 protons, so that means I have 8 plus charges. They make me bigger so you can see it again. Yeah. 8. 1, 2, 3, 4, 5, 6, 7, 8. Ooh, you can kind of see that? Not really. Well, I can't zoom in, so we're going to go for it. So we have 8 here, and then it says I have 8 electrons. Helpful. 1, 2, 3, 4, 5, 6, 7, 8. For every proton, if there's an electron, they cancel each other out. It's neutral. So we need to figure out if they all cancel. Proton, electron. Cancel. Proton, electron. Proton, electron. Plus, minus, plus, minus, plus, minus. There is nothing left over on the outside. There's no extra protons. There's no extra neutrons, which means we are going to have a neutral atom or no charge. Now, because there's no charge, it is an atom. It is not an ion. An ion is an atom with an unequal protons and electrons, unequal charges. So it's an atom. Now, when I do the ion symbol wants to see the element symbol in the middle and the charge in the upper right-hand corner. O is my symbol for oxygen. Now, in order to do a superscript or a subscript, I need to hit Control. I don't know if you'll be able to see it. Control and the period button gives me a superscript. You just hit Control and period to bring it back. Control comma gives you a subscript. So I want a superscript. I have a charge of 0. So that's helpful for us. Let's make this a little bit bigger so that we can see. Boom. Now, you don't always have to include the 0 here. It's okay to not put that. So your symbol can look like that, or it can look like that. It's up to you. Either way is accepted. So again, in order to figure out the charge, we had to look at how many plus charges we had, how many minus charges we had, and if there was anything left over. Okay, let's do the same thing for this particle right here. A particle contains 9 protons, 10 electrons. Ooh, unequal numbers. What are we going to do? So, maybe over here. Fluorine is going to be our particle in question because it has an atomic number of 9. And we know that it has 9 protons, and so it has to have an atomic number of 9. So my element is fluorine. Now, what is the charge going to be? There's a pretty easy way that you can figure out charges, if you want to think about math, your charge is equal to your number of protons minus your number of electrons. Why is it minus? I will tell you. Electrons have a negative charge. So if I'm subtracting these two numbers here, if I have more electrons than protons, I'm going to end up with a negative charge. We need to pay attention to that. So it's protons minus electrons. So in our case, my number of protons is equal to 9. My number of electrons is equal to 10. So 9 minus 10 equals negative 1. So my charge is equal to a negative 1. I have one more electron than I have protons. So I have one more minus charge. So because I have a charge, because this is not 0, that means I have an ion. Cool stuff. Now, in order to do the symbol, again, I need to go to, make this a little bit bigger so you can see. I need to figure out what my element symbol is, and I kind of saw that. I'm in the way. My element symbol is an F. And then I'm going to put this -1 in the upper right-hand corner of my symbol. I'm going to hit Control. I'm going to hit period. I hope you guys could see that. And I'm going to do a -1. There's my ion symbol. Boom, done. Ready to go. So again, we're having to identify what type of element something is from the number of protons or from your atomic number. That's what I asked you to do for ions. Now let's talk about isotopes. Isotopes are atoms with different mass numbers. And remember, the protons are what control the type of element, which means the only thing changing here in order to change the mass number is our neutrons. So we have different numbers of neutrons. Numbers. Okay, so carbon, 6 protons, 8 neutrons. Let's figure out what it's trying to do. My atomic number is equal to my number of protons, which means we have an atomic number of 6. My mass number is equal to protons plus neutrons, which means I have a mass number of 14. Now, I don't trust myself with math, so I'm going to do it in my calculator. 8 plus 6 equals 14. Look at that. I should trust myself with math. Now, we're doing the name. For an isotope name, we do the full name of the element, a dash, and then the mass number. Let me write that down. Full name. Yep. Element, dash, mass number. That's what it is. So in this case, our element is carbon. And dash, here's the mass number, 14. Carbon 14. Now, how do I do the isotope symbol? I'm going to scroll down a little bit because here we can see our full ion isotope symbol right there. Maybe. There we go. So for the symbol, this X is my element symbol. And I'm going to put that in there. Actually, I'm going to insert a, no, I'm not going to do that. So I'm just going to make this a little bit bigger. And we're figuring out my isotope symbol. So the middle portion is C, because that's the element symbol for carbon. And then I want to put my mass number in the upper left-hand corner. So I'm going to click right here. And I'm going to do Control, period. And I'm going to put my mass number up here, which is 14. What is teeny? Let's fix that a little bit. There we go. Okay, so in the bottom left-hand corner is my number of protons. I'm going to do this, Control, comma. That brought me down. And I'm going to say my number of protons, or my atomic number, is equal to 6. There we go. Now it pushes it off a little bit here. That's okay. So there's my isotope symbol. We didn't say anything about electrons, so we're assuming that it's neutral, which means I do not need to put a charge in the upper right-hand corner. We're good. Let's do another example. Silver has 47 protons, meaning its atomic number is 47. It has 22 neutrons, which means I have to do 47 plus 22, which I think is going to be 69, but we're going to test that anyways. plus 22. Yes, it is. Look at that. Oops. Wow. 69. The name of this is going to be silver dash 69 because I have to put my mass number there. And then my isotope symbol again. Oops. My isotope symbol is going to be the element symbol for silver. What is that? It's not Si because that's silicone. We better double check our periodic table. Here's silver. Element symbol is Ag. I know it's a weird one, but it's okay. We'll get through it. Ag. Here is my, remember in the top I put my mass number. So my mass number is 69. And then, my bottom is going to be my number of protons or my atomic number, which is 47. Lucky for us, we're done. Okay, so that's how you write isotope symbols. Now I know that it was neutral because I didn't put, there's no electrons here. If I would have specified that it was an ion or I specified if there was a different number of electrons, then it would have been able to maybe have a charge here. And that's what's happening here. So in the third part of your ions and isotopes practice, you had to fill out this table based on the symbol. And so there's a lot of information within this symbol. My atomic number is equal to my number of protons, which is this number right here, this 12. So that means my atomic number is equal to 12. We're going to do this. Make all of you that. Okay. My mass number, I don't have to do any calculations. My mass number is written right there. 25. That's my mass number. How do I know? Because I'm looking at this little template here. And I know that in the upper left-hand corner of my ion isotope symbol is my mass number, 25. My charge is in the upper right-hand corner, which is a +2. Okay, that's all the information that I got just from this, just looking. I didn't even have to do any calculations. Now I have to do a little bit of calculations. My protons are equal to my atomic number. This has a charge on it, which means my protons and my electrons are not the same thing. So let's hold off on that. My neutrons is my mass number minus my atomic number, which I believe is 13. But again, I don't trust myself with math very much, so I'm going to have to double check. Oh, look at that. I should start trusting myself. Okay, so my number of neutrons is my mass number minus my protons. So my mass number, 25, minus my protons, which is 12, and I get 13. Now, my electrons. My electrons is equal to, we have to figure out the number of electrons by looking at the charge. So this charge says I have 2 more plus charges than I have minus charges. So that means I have 2 more protons than I do electrons. If I have 12 protons, that means I'm going to have 10 electrons. And we're going to double check using, where did I put that? Oh, using this guy right here. Copy. I'm going to put it down here. Paste. So my charge is equal to my number of protons minus my number of electrons. We're going to test that out. So if I have 12 protons and I have 10 electrons, I'm double checking my work up here. That means 12 minus 10 is equal to 2. That's a +2, and that is my charge. So we know that we figured out our number of electrons correctly. Cool? Cool. Let's do the same thing for sodium. Sodium, right here. Here's our ion isotope symbol. It's a little complicated, but it's doing all right. We have 22 for our mass number. We have 11 as our atomic number. And we have a +1 charge. Beautiful. That means my protons are equal to my atomic number. My neutrons are 22 minus 11, which is 11. Now my electrons are equal to, we have to figure it out. We have to figure out how many electrons we have. This is saying I have 1 more proton than I have electrons. I have 11 protons, so I think I'm going to have 10 electrons. Let's double check that. Charge is equal to number of protons minus the number of electrons. Number of protons is 11 minus my number of electrons, which is 10. Do that math, that equals 1, which is a positive number. My charge is plus 1. There's your double check. Double check it every single time. If you want to, you can absolutely draw out these pluses and minuses right now. Eventually, you'll get to a point where you should be able to just say, oh, I have more protons than neutrons. Here's how many more I have, and be able to do the math that way. But that's how you fill out this table. And that's all the practice that I've given you. I tried to pick out the commonly missed questions and tried to pick out questions that you guys had for me. But that's it. That's what we're looking at. So if you have any questions or comments or concerns, please comment on the video in Google Classroom, or send me an email if you don't want to comment a public question or ask a question into the entire class. Please, please, please watch this video. I'm so happy that you did, because, you know, if you're listening to me talk right now, that means you have. But I miss you all. I love all of your faces. And I'm hoping that I will get to see all of you very soon. Okay? Happy learning. Good luck with everything. Next week, we get to learn about chemical reactions, and I'm super excited. So hit me up if you have questions. I miss you all very much. Saying goodbye on these videos is the most awkward thing on the planet, because I'm saying goodbye to an empty room. Okay, goodbye.